Hello everyone, welcome to my channel. So today we are going to do Leetcode bi-weekly challenge. Third, I guess this, yeah, second question. Find polygon with largest perimeter. So let us first see this question, then about the constraint, and then finally the coding part for the same. So you are given an array of positive integers nums of length n. A polygon is a closed plane figure that has at least three sides, and the longest side of the polygon is always smaller than the sum of its other sides. This was the basic thing which we learned in our junior classes, basically in our school time when we were learning about polygons. So, conversely, if you have k greater than equal to 3 positive real numbers a1, a2 up to ak, where a1 is less than equals to a2 up to less than equals to ak, and a1 plus a2 up to ak minus 1 is greater than ak, then there always exists a polygon with k sides whose lengths are a1, a2 up to ak. So the perimeter of a polygon is the sum of the lengths of its sides, and we are required to return the largest possible perimeter of a polygon whose side can be formed from nums, else we will be returning -1 if it is not possible to create the polygon. So basically, as per the formula, this is a mathematical question, but it is not just a pure mathematical question. We would be required to use something to store, and like that we would be required to just get our answer. So here in this first, nums equals to 5, 3 times 5, which is there. So if we see that 5 plus 5, basically when there are three sides, so it could be a triangle, right? And triangle, other two sides, that is 5 plus 5 equals 10, and here 5. So if we see that C is basically greater than A plus B, so that's why here polygon is possible. 1 minute. Hmm. बोर्ड को क्या हो गया? So basically here polygon would be possible, and then when we see here, so here you can clearly see that here there are multiple sides which are given to us, right? So in these multiple sides, we need to check that how many sides we can take and which combination we can take so that it can become a polygon. So here, if we sort it in descending order, 1 minute, this one is not working. So let me show you on whiteboard itself. Mm, So if we take this, I don't know what happened. Now it is not copy pasting. Okay. So if we take here, hmm, so see, here if we take, if we sort them in descending order, so 50, then 12, and then 5 would be there, 3 would be there, 1 would be there, 1 would be there, right? So now if we start checking from the last side, and if we simply add them up, like 1 plus 1 would be 2, right? And 2 is basically, and 3 is here greater than, oh sorry, 3 is here, yeah, greater than 2. So here polygon won't be possible. So now we'll check and add it. So it will become 5, and here it is also 5, right? So here if we see they are equal, right? So here, 1 minute, I missed something now. 1, 1, 2. Hmm. मेरे लैपटॉप को कुछ हो गया है. Okay, so here 5, then 3, 3, 2, 1 and 1. Now when we add them, it becomes 2, it is equals to 2, so no polygon could be formed. So we will add them up. Now it's 3 and 3 is less than 4, right? So here polygon could be formed. So we will keep it with us that this is one of the possible polygon which could be formed with the parameter 3 plus 4, 7. Now we will check for this one. We'll check when we add them up, 3 plus 4 it becomes 7, right? And 7 is basically greater than 5. So this is another possible polygon. So we will add them up, 7 plus 5. So this would be, this is maximum, then this, right? Basically greater than this. So this is at present maximum possible parameter. Now, when we do this 5 plus 7, it will become 12, right? So here we check, it becomes equals to 12. So no polygon possible, right? And then, so at this point, we won't check because here no polygon would be possible, right? And then next if we check, see here, then this is the case. And then if we add 12 plus 12, so it becomes 24. And here it is 50. Although it is less than 24, but now the thing is that any polygon, if we try to make polygon out of it, it won't be possible at this point of time, because here we can here we can see that 50 is basically greater than 24, right? So here the sum of other all other side is basically less than one single side, right? So that's why there won't be any possibility of a polygon at this point of time. Means no polygon at this point. Please know this, but at this was the latest one at which the polygon was possible. And when we add them all, so it becomes 12. So this is the largest possible parameter for this set of sides which is given to us. And they have not asked for number of sides, so it's fine. They have just asked for the largest possible parameter. Now this test case which is there, 5, 5, 50. So in this 5, 5, 50, we see 5, 5 and 50, right? So these two sides which are there, it becomes 10, right? Which is already less than 50. So again, no polygon possible. So that's why we will be returning -1 as our answer. So this is the thing which we are required to implement in our code. Basically, we just need to check that at a particular point of time, whatever sum of the sides which are there, is it greater than the side at which we are? If that is a true, then we will keep that with us as a potential answer. And we'll move ahead and check for other sides which are there so that we can check that is there any possibility that there could be much more larger size parameter. So that's why we'll go ahead and check, and whatever maximum would be there, we will be returning at the end. So this I've explained. Now comes the part that how we are required to code it. The thing is that n could go up to 10 raised to the power 5, and number inside could go up to 10 raised to the power 9. So when we are adding them up, it can increase the limit of integers. So that's why we would be required to take our answer as long int. So now let us check the function. So here also it is given as long int to be returned. So now first thing is that we will be sorting our nums array which is given to us in decreasing order. You can sort in increasing order also. It's like up to your choice as per how you want to implement it. And here at the first stage only we will check for the edge case that if n is less than 3. Although here it is already mentioned that n is basically greater than or equals to 3. So even we can remove this edge case, still it will work. Now here comes the main part. So the thing is that how I have solved this question is by taking sum of each element. Here although I'm saying it as pre-sum, that is prefix sum, but I'm not doing it the way prefix sum is. So here whatever would be at the last of nums of this nums, basically here you can clearly see that we have sorted that in decreasing order. So if I take the example, means if I take this example itself, this one which is there, so the numbers would be sorted in decreasing order. And how it would be like, means 50 would be here and 12 is here, and here it would be 5, and here it would be 3, here it would be 2, and here it would be 1, and here again it would be 1. So now what I'm doing is I'm taking from the last itself because I want to sum these up, right? So that's why basically I would have named it as suffix sum rather than prefix sum. So here I'm putting whatever is at the last n minus 1 into this. Here I've already given it as an n n sized. So I'm starting from the last second and going till 0. So here I'm checking if nums of I, means here I'm checking for the potential parameter. So if my present nums of I is less than the prefix sum of I plus 1, then at that point of time I'll check that what is maximum parameter at that point, and prefix sum I plus 1 plus nums of I, that I'll add up, and then here I'll update this pre-sum, which would be the next one. And then at the end I will be returning whatever potential parameter would be there. At the first, I'm initializing it with -1 itself, so that if we never fall into this condition, it will be returning -1. That is no valid polygon found. So this is how I coded this question. And even before seeing this code, you can, as I've already explained, so you can also try by your own version as well, because this question could be done in other ways as well. This is like what I did in my contest. So basically now comes the part for the time complexity. So time complexity of this is, you can clearly see it here, it is order of n, and apart from that here we are sorting it. So here the time complexity becomes n log n, and the space complexity here is that we are storing that, right? So that's why space complexity is order of n because of this. So this was all for this particular question. If you have any doubt, you could comment that down. So if you really like the explanation, do like, subscribe to my channel, and also share among your friends. So this was all. Thank you.